Inverse trig functions. Let's just talk about something first. If somebody writes cosine cube of y, or cosine to the third of y, they mean this. If they say cosine 5 of y, they mean cosine of y to the 5. If somebody writes this, you might think that it means that. It doesn't. It's silly notation. One should not change the rules in the middle. This negative 1 means inverse. It does not mean cosine x to the negative 1. If you want to write cosine, it's not cosine y to the negative 1. If you want to write cosine y to the negative 1, you have to write it that way. That means 1 over cosine y, which happens to be secant y. Okay? You cannot use this symbol to mean this mess. Sorry. Okay. Having gotten that out of the way, so negative 1 always means inverse. If you have that cosine inverse of x equal y, this means that cosine of y is x. You can interchange those two as long as you get rid of the inverse sign. But that's not it. And x is in between 0 and 180. If I tell you that the sine inverse of x equals y, this means that the sine of y equals x. And that x is between negative 90 and positive 90. Tan inverse of x equals y. This means, can always interchange those, means the tangent of y equal x, but don't put the inverse. And this is the key part, and x is in between negative 90 degrees and 90 degrees. So, now that we have our definitions, let's try to work out some of these. Now, what I do want to say is this. This is in quadrant 1 and quadrant 2. The cosine is positive in quadrant 1, but negative in quadrant 2. Negative 90 to 90, well, that's in quadrant 1 and quadrant 4. Quadrant 1, the sign is positive, and in quadrant 4, the sign is negative. Negative 90 to 90, once again, it's in quadrant 1 and quadrant 4. In quadrant 1, the tangent is negative, and positive. In quadrant 4, the tangent is negative. Now, please notice that every one of them has a quadrant 1 in its answer. The other quadrant that it can be in, quadrant 1 is always positive. Quadrant 1 is always positive for these three trig functions. In fact, all trig functions. Quadrant 2, the other quadrant is negative. Quadrant 4, the other quadrant is negative. Quadrant 4, that quadrant is negative. Sine inverse, cosine inverse, tan inverse, the answer is allowed to be in quadrant 1, and it has to be a positive answer. Otherwise, depending upon whether it's sine, cosine, or tan inverse, they're in either quadrant 2 or 4, and they're negative. All right. Hopefully that was clear. Now, if you want to find the sine inverse of a half, first give it a name. Call it x. This here is an angle. How do I know that? Because this means that the sine of x, this is an angle. This is an angle, because the sine of x equals a half. That's an angle, but whatever x is, it equals this. This is an angle. And x is in quadrant 1. Why? Because the sine of x is positive. Okay, so we go into quadrant 1. There's x. The sine of x is 1 over 2. Oh, I recognize this. Oh, yeah. X is 30 degrees. That is the sine inverse of a half. That is what we called x, is 30 degrees. It has to be that the sine of this angle is a half, and that this angle is between negative 90 and 90. And it is. What about the cosine inverse of negative square root of 3 over 2? Well, let's call it something. Let's call it x. Well, this means that the cosine of x equals negative square root of 3 over 2, and x is in quadrant 1 or 2. Can't be in 1 because the cosine of x has to be positive in quadrant 1. Cosine inverse is only defined in quadrant 1 and 2. Okay, so we know we're in quadrant 2, and this is x, that's my reference angle, and we get the adjacent is negative square root of 3, the hypotenuse is 2, this is 1, so that's 30 degrees. So x must be 150 degrees. The cosine inverse of this, which we're calling x, must be 150 degrees, which is 180 over 6. That's 30 times 5. That's another way of writing the answer. Let us try another problem. What about the tan inverse of negative square root of 3? What is this equal? We'll give it a name, maybe t. So, you know that the tangent of angle t is negative radicals 3. Tan inverse is only defined in quadrant 1 and 4. But the tangent of an angle in quadrant 1 will not be negative. It's negative in quadrant 4. And just remember that that's the same as negative square root of 3 over 1. So tangent of that angle, it's going to be a negative angle. It is opposite over adjacent. That's 2. This angle is 60 degrees, the reference angle. So the angle we want is negative 60 degrees. Okay, so the tan inverse of negative square root of 3 is negative 60 degrees, which is 180 over 3. And I put the minus in front. The cosine inverse of 5. We want to figure out what that equals. Oh, let's let it equal t. Well, this means that the cosine of t is 5, and I'll stop there. There's no solution. The cosine of no angle, regardless of what quadrant we're in, equals 5. The cosine of t is always in between negative 1 and, between negative 1 and 1. It is never 5. So, no solution. Let us try a different type of problem. What is the sine inverse of 1/2? Well, this here is an angle. Let's call it t. So basically, we want to know what the sine of t equals. That is what we're waiting for. Well, if the sine inverse of 1/2 equals t, that implies that the sine of t equals 1/2. Ooh, I'm done. I know what sine of t is. If this here is an angle, t. So we want to find the sine of t. And once I have the sine of t, I'm done. Well, this is what we define t to be. Sine inverse of 1/2 is t. But that means the sine of t is 1/2. I'm done. I know what sine of t is. Let's try another one. Suppose you're asked to find the cosine inverse of 2/3. This here is an angle. Maybe I call it t. So I want to know the cosine of t. I want to know what the cosine of t is. Well, this tells me, that the cosine inverse of 2/3 is t. That means that the cosine of t is 2/3. And this is possible. It's not outside of negative 1, 1. So the cosine of t is 2/3. And that problem is done. What is the tangent of the tan inverse of 17? Well, that's an angle, and we want the tangent of that angle. Just going by definitions, and the tan inverse of 17 equaling t, well, I can interchange those, and I get that the tangent of t is 17. Now, tangent isn't bounded by negative 1, 1. Tangent can go from negative infinity to positive infinity. So, yep, the tangent of t can be 17. In this problem, it is 17. What is the cosine inverse of 32? Well, cosine inverse of a number is an angle. Oh, and we want cosine of this. That is, we want cosine of t. Well, the cosine inverse of 32 equal t. That means that the cosine of t is 32. But no, this has no solution. Cosine of t cannot be more than 1. Cannot be less than -1. What about the sine inverse of 1/4? Well, sine inverse of a number is an angle. And in this case, we want the sine of the angle. Okay, I'll do my best to try to find it. Well, we know that sine inverse of 1/4 is t. I can switch those as long as I get rid of the inverse. Ooh, sine of t is 1/4. That was pretty straightforward. Now, the next one says that they want us to simplify this. The cosine of the sine inverse of 3/5. So we'll call that t, and we want the cosine of t. Okay, so the sine inverse of 3/5 equals t. That means that the sine of t is 3/5, and since this is positive, t is in quadrant 1. I didn't stop right here because they're not asking me for their sine of t. They want the cosine of t. Well, the sine of t is opposite over hypotenuse. Oh, that's 4. Oh, you want the cosine of t. All right. It's adjacent over hypotenuse. The cosine of the sine inverse is 3/5 is equal to 4/5. What about the sine of the cosine inverse of 2/7? That's an angle, and I want the sine of that angle. Well, if cosine inverse of 2/7 is t, that means that cosine of t is 2/7. Since it's positive, t is in quadrant 1. Here is angle t. The cosine is 2/7. This must be the square root of 45. Because when I square that, I get 45. And when I square that, I get 4. And when I add them up, I do get 7 squared. For the record, this is square root of 9 times square root of 5, which is 3 radical 5. So what is the sine of t? It's the opposite, 3 radical 5 divided by the hypotenuse. So this is 3 radical 5/7. What if you wanted to find, or you were asked to find, the tangent of the sine inverse of 2/3? Well, this is an angle, and we want to know what the tangent of the angle is. Okay, well, by definition, this equaling t, sine inverse of 2/3 equal t, that means that the sine of t is 2/3, and this is only defined in quadrant 1 and 4, and since it's positive, t is in quadrant 1. So I go in quadrant 1, I draw my angle t, the sine is 2/3. this must be the square root of 5. Because when I square that, I get 5, plus when I square that, I get 4, and that does equals 3 squared. And we want the tangent of this angle, which is opposite over adjacent, is 2 over square root of 5. I'll multiply by 1 as square root of 5 over square root of 5. So the bottom is rationalized, and the top is 2 square root of 5. And that is what this equals. Suppose that you want the tangent of the sine inverse of negative 2/3. Well, this here is an angle. Let's call it t. So we want the tangent of t. We know that the sine inverse of negative 2/3 is t. Well, that means that the sine of t is negative 2/3. That means we are in quadrant 4. Sine inverse is only defined in quadrant 1 and 4, and it's positive in one. It's negative in the other. Okay, so we are in quadrant 4. This is a angle t, to be honest, and the sine of the reference angle is opposite over hypotenuse. That's square root of 5, just like it was a moment ago. Square that, get 5. Square that, get 4. 5 plus 4 is 3 squared. Now we want to know the tangent of this reference angle. Well, it's opposite over adjacent. It's negative 2 over square root of 5, which really makes me want to look at the last problem, which means we're doing the same problem again, and I'd be embarrassed if I got a different answer. Okay, so we should get negative 2 square root of 5 over 5. Oh, okay. Actually, it wasn't different. It was different. This was positive 2/3. That number is negative 2/3. Okay. What if we want to compute the sine of the cosine inverse of 7 over 10? So, this is an angle, and angle t, and we want to know what is the sine of angle t. We just want that. Well, what do we know? We know that the cosine inverse of 7 over 10 is t. That means that the cosine of t is 7 over 10. And since this is positive, t must be in quadrant 1. Because all trig inverses are positive only in quadrant 1. So we're in quadrant 1. Actually, that is t. And the cosine is 7 over 10. This must be the square root of 51. Because 7 squared is 49. And I want to end up with 10 squared or 100. So what I square better be 51. That's why I put the square root of 51. 49 plus 51 does equal to 10 squared. So the sine of the angle is square root of 51 divided by the hypotenuse. The square root of 51 over 10. Okay. Now, what is the sine inverse of the sine of 20 degrees? Well, let us call this t. let's call that t. Now, we know that the sine of t is equal to the sine of 20 degrees. Now, the sine of 20 degrees is in quadrant 1. So this is a positive number. That means that the angle has to be in quadrant 1. Well, that is in quadrant 1. The sine of 20 degrees equals the sine of 20 degrees. That is t, which I'm calling this, is 20 degrees. It is 20 degrees. What if I asked you, what is the sine inverse of the sine of 150 degrees? Well, let's call this t. This means that the sine of t is equal to the sine of 150 degrees. Well, 150 is in quadrant 2. Hypotenuse is always positive, and the opposite is positive. This is positive, which implies that t must be in quadrant 1. That angle is 150 degrees. I want to know the sine of what angle in quadrant 1, that is the sine of what angle between 0 and 90 equals the sine of 150. And the answer is going to be the reference angle. The sine of 30 degrees is equal to the sine of 150. That is, t is 30. And since t was defined to be this, this equals 30. Suppose you have the following. What is the cosine inverse of the cosine of 74 degrees? Well, define it to be t. So this means that the cosine of t is the cosine of 74. But this is between 0 and 90. And the cosine or the trig of any angle in quadrant 1 is positive. This is positive. Okay, so that implies that just give me a second, please. This implies this, and t is in quadrant 1. But that angle is in quadrant 1. Of course, the cosine of 74 degrees equals the cosine of 74 degrees. And it's in 74 is in quadrant 1. Okay, this is an obvious statement. So, the cosine inverse of the cosine of 74 degrees, this, equals t. And I'm saying t is 74 degrees. What about the sine inverse of the sine of 210 degrees? Well, like always, let it equal t. Well, this means that the sine of t is equal to the sine of 210, and t is in, well, the sine of 210. That's 180 and some more. The opposite is negative because it's going down. Adjacent is negative. Hypotenuse is positive. The sine of 210 is negative. It's opposite over hypotenuse. The sine of 210 is negative. That means, now sine inverse is only defined in, that means the angle T, what it equals, is in quadrant 1 or quadrant 4. Well, it isn't positive, it isn't negative in quadrant 1, so T is in quadrant 4. I want to know what angle this can be to give me the same as the sine of 210. Well, this reference angle is 30. This reference angle should also be 30. Since I have to be between negative 90 and positive 90, I can say it's 300, but I can call it negative 30. I can call it negative 30. This mess is equal to negative 30. That is, the sine of negative 30 equals the sine of 210. And this number is between negative 90 and 90. It's a game. You have to play the game. Let's try the next one. The sine inverse of the sine of 210 degrees. Well, let's call this t. So we want the sine of t to equal to the sine of 210. And t can only be between negative 90 and 90. Well, one second, please. So let us do the next problem, the real next problem. The next problem is the cosine inverse of the cosine of 420. Well, any trig inverse is defined in 2 of the 4 quadrants. This isn't even in one of them. The cosine of 420 is the same as the cosine of 60. I would do that right away, because 360 and then 60 more. The cosine of 420 and the cosine of 60 the same. I would call that t, and I would solve this problem here. Okay. This tells me that the cosine of t is equal to the cosine of 60 degrees. But if you give me an angle in quadrant 1, well then t should be that angle. This is equal to 60 degrees. For example, if you give me the or ask me the cosine inverse of negative 20, let me not do that. If you asked me for the sine inverse, of the sine of negative 22 degrees, well, this equals t. And I want the sine of some angle that equals to the sine of negative 22 degrees, and t must be in between negative 90 and positive 90. Well, I know whether I'm in this interval or not. I know sine of negative 22 degrees equals the sine of negative 22 degrees. But wait a minute. that is in between negative 90 and 90. So this is just negative 22. The sine of that angle equals the sine of negative 22 degrees, and this angle is in between negative 90 and 90. Okay, so it's somewhat immediate. What about the tangent inverse of the tangent of 212 degrees? Now, 212 degrees is 180 and just a little bit more. For the record, 32 more. But that's quadrant 3. Tan inverse is only defined in 1 and 4. Okay, so this equals some t. That means the tangent of t must equal to the tangent of 212. And since the tangent here is negative, opposite over, that's also negative. It's going down, it's negative, going to the left. So the tangent of this angle, is positive. Okay? So this here is positive. So tangent of t is positive. That means it's in quadrant 1. Okay? The reference angles are the same. This equals to 32 degrees. The next problem's a little bit interesting. What if you want to find out the cosine inverse of 2 cosine 30 degrees? Well, this is equal to t. Wonder what that is. Let's try to figure it out. Well, the cosine of 30 degrees is, the triangle looks like that. So the cosine of 30 degrees is adjacent over hypotenuse. Adjacent over hypotenuse. Well, 2 times it will be square root of 3. Okay. So we have the cosine inverse of square root of 3 equals 2. This means that the cosine of t is the square root of 3. But that's bigger than 1. So there's no solution. Well, what if I changed it a little bit? What if I said, what's the sine inverse of... Well, I'm sorry. I don't want to change that cosine. What if I had asked, what is the cosine inverse of 2 sine of 30 degrees? Well, the sine of 30 degrees is opposite over hypotenuse. It's a half. And I have to double it, so I get 1. This is just the cosine inverse of 1. Well, let it equal t. That means that the cosine of t is 1, and t is in between 0 and 180. Well, if you know the cosine graph, oh, it's 1 at the very beginning. So, t is 0 degrees. This mess is 0. The cosine of 0 degrees, which is 1, is 2 times sine of 30. But 2 times sine of 30 is also 1. Now, here's a good problem. The sine inverse of a half plus cosine inverse of a half. Now, this is a theta 1 and that is theta 2. Now, we can use the sum rule. We can say the sum of theta 1 plus theta 2 is the sine of theta 1 times the cosine of theta 2 plus the sine of theta 2 times the cosine of theta 1. And that would work, but there's something more going on here. We know from this first statement that the sine inverse of a half, is equal to theta 1. That means that the sine of theta 1 is a half. Okay. So here's theta 1 in a right triangle, opposite over hypotenuse. Okay. Now, we also know that the cosine inverse of a half is theta 2. That is, the cosine of theta 2 is a half. Oh. The cosine of that angle, adjacent over hypotenuse, is a half. Oh. That's theta 2. Let me be sure. It better be true that the sine of theta 1 is a half. Sine is opposite over hypotenuse. Got it. It's a half. The cosine of theta 2 must be a half. Theta 2. Adjacent, yeah, that's 1 over 2. Yeah, that's right. But if this is 90, those two must add up to the other 90. In other words, this problem is nothing more than the sine of this plus that, which is 90 degrees. And the sine of 90 degrees is 1. This is just a complicated way of saying 1. That's just another way of saying that the angle is 90 degrees. If the sine inverse of some number plus the cosine inverse of the same number, that's going to equal to 90 degrees, as long as those numbers are not outside plus minus 1. Now, if you didn't see this, well, you missed out on the problem, what the meaning of the problem was, but that doesn't mean you can't do it. What is the sine of the sine inverse of a half plus the cosine inverse of a half? So that's theta 1, that's theta 2, and we know that the sine of theta 1 is a half. Okay. This theta opposite over hypotenuse. Oh. This is 30 degrees. Okay, that's 30 degrees. Cosine of theta 2 should equal a half. That's what this says. Draw a triangle. Let's keep it labeled right. The cosine of theta 2 is adjacent over hypotenuse. Oh, So this is square. Oh, this is 60 degrees. Okay. Oh, they're just asking me the sine of 30 plus 60. Now, you want to use the sum rule, go ahead. I would add first and say, oh, the sine of 90 degrees is 1. Now, this, we were able to do it the longer way because we knew what angle to take the sine of to get a half and what angle to take the cosine of to get a half. But if this would have been 1 over 7, you wouldn't have known. You really need to realize that this plus this is 90 degrees. I was able to see that as a student, so can you. So, on that note, what would be the answer to the cosine of the sine inverse of 3/5 plus the cosine inverse of 3/5? Since I'm taking the sine inverse of the same number that I'm taking the cosine inverse of, and I'm adding them up, this will be 90 degrees. And the cosine of 90 degrees is 0. This is 0. Okay? Now, you will not be able to do this separately. You can't say, well, I'm gonna call this theta 1, I'm gonna call this theta 2, and because the inverses are both positive, 3/5 is positive, I'm in quadrant 1. So I know that the sine of theta 1 is 3/5. So here's theta 1. The sine is 3 over 5. I even know that's a 4. But I don't know what this angle is. And you say, well, maybe something will come to me. I know that the cosine of theta 2 is also 3/5. You know, you can draw another triangle if you like. The cosine is adjacent over hypotenuse. You even know that's 4. But you don't know this angle either. And maybe if you think hard enough, you'll say, wait a minute. If this triangle definitely by design lived up to this. But if I put theta 2 there, the cosine of this angle is also 3 over 5. I don't need the other angles. And, I'm computing this cosine of theta 1 plus theta 2, but that sum is 90. So it's the cosine of 90, which is 1. It's always going to be 1. The cosine inverse of x plus the sine inverse of x equals 90 degrees if and only if x is between -1 and 1. Okay? The cosine inverse of 23.4 degrees plus the sine inverse of 23.4 degrees. This is equal to 90 degrees or 180 over 2. That is pi over 2. As long as these are the... Oops, I made one mistake. These should not be angles. I apologize. It's a major mistake. It must be a number. Like 0.78. 0.78. they can even both be negative. The cosine inverse of a number plus the sine inverse of a number is always, you know what, let's make these positive. The sine inverse of a positive number less than 1 plus the cosine inverse of a positive number less than 1 will be 90 degrees. I guarantee it. I guarantee that. Okay. So, 2 more problems. How about this one? Simplify. What is the sine of the tan inverse of x? Well, this is some angle, and we want to know what the sine of the angle is. Well, we know that tan inverse of x is theta. That means that the tangent of theta is x, which is x over 1, and theta is in quadrant 1 or quadrant 4. That's where tan inverse is defined. Well, let's see what happened in quadrant 1. The tangent of the angle is x over 1. So this hypotenuse must be this squared plus that squared. X squared plus 1. Alright, well, the sine of that angle is opposite over hypotenuse. But let's not say we're done, because x theta can be in quadrant 4. And the tangent of theta is x over 1. Opposite over adjacent. Adjacent's positive, that's key. Nope, and x is negative. Doesn't mean we have to put a negative sign in front of it, because that would make it positive. This is x squared plus 1. Now, the sine of that angle is opposite over hypotenuse. The same thing. There's my answer. That is my answer. No question about it. Now, what if I change sine and interchange sine and tangent? What if I have the tangent of sine inverse of x? So this here is an angle. Call it theta. So, again, we want the tangent of theta. I just renamed it. So instead of saying the tangent of this long, complicated expression, I just call it the tangent of theta. So we know that sine inverse of x is theta. That means that the sine of theta is x, which is x over 1, and theta is in quadrant 1 or 4. Okay, well, let's see what happens in quadrant 1. There is my angle theta. The sine of the angle is opposite over the hypotenuse. Okay? The other side gets the hypotenuse squared minus the other leg squared. The tangent of this angle is opposite over adjacent. But does anything change if I'm in quadrant 4? I always call this theta, but really this angle is theta. Now, we know that the sine of theta is x over 1, but we can use this reference angle. Opposite over adjacent, x over 1. This must be excuse me a moment. Oops. The sine of the angle is x over 1. So the opposite is x, the hypotenuse is 1. This leg is the hypotenuse squared minus the other leg squared. And the tangent of this angle is opposite over adjacent. Same exact answer. Okay. All I've done in these problems was 100% use the definitions. Sine inverse of a number, between plus and minus 1 is equal to an angle. If somebody asks you what sine inverse of 22 degrees is, you say, I don't know. Okay. Now, if somebody asks you, what is sine inverse of pi over 4? See, pi, it's a number. It's about 3.14. And pi is also a number of radians. If we're talking about an angle, then pi is our number of radians, pi radians. If we're just talking about a number, if somebody says to you, how much is pi plus 7, or about, you should say, oh, it's about 10.14. No radians, no degrees, just a pure number. Okay, somebody asks you, well, what's 30 degrees plus pi? It's reasonable that they mean pi radians. And you can say it's 210 degrees. Because that's 180 plus 30 is 210. Or you can realize that 210 is 7 times 30 degrees. And 180 degrees divided by 6 is 30. Multiply it by 7. Somebody asks you what that is. You either say this or you say that. But this pi is understood to be radians. If somebody asks you what's 30 degrees plus 7, okay, your answer should be, well, pi over 6 is 30 plus 7. You should either say this or 7 plus pi over 6. Or if you want to be fancy, 42 plus pi all over 6. Because that is 7 radians. It is not the number 7. Okay, this number, pi, is approximately 3.14. If I divide it by 4, it's less than 1 and it's bigger than 0. That is, this number is 0 is bigger than negative 1. This number is in between negative 1 and 1. That is a pure number. This equals some angle. That equals some angle. What do I know about the angle? The sine of the angle is pi over 4. Since that is less than 1, okay, it's less than 1. That means 1, okay, it is less than pi over 2. A quarter of a pi is less than half of a pi. And where did I come up with half of pi? Because that's 90 degrees. It's between 0 and 90. We are in quadrant 1. And all I can tell you about t is that it generates 4 squared minus that squared. It generates this triangle. That's all I can tell you about t. I mean, I can tell you the cosine of t and the tangent of t. I mean, with the calculator, I could type in the sine inverse of pi over 4 and get, depending upon the setting on your calculator, degrees or radians. What I'm getting at is, in this problem right here, pi is not pi radians. It is the number which is approximately 3.14. That's all I know about pi in this problem. It is not 180 degrees. I mean, that would be like saying 7 equals 13 or 9 equals 9 inches. Why does 9 equal 9 inches? Why should pi equal pi radians? We're not talking about radians. If I give you a 12-inch ruler and I say, how long does this measure? And you say 9. I'll assume you mean 9 inches. Okay, that's reasonable. But right here, it's not radians. Okay, as I said, that completes this video. Use the definition. That's all you need to do.